Hello everybody, welcome, how are we doing? Welcome to another stream. So, last stream, this is just my levels. Yeah. So last stream we got essentially a 3D transform data structure in. So, um, we basically tested it out, right? So we just, like, end of two streams ago we started writing it. This 3D transform. It's basically a 3x4 matrix with an implicit fourth row, I should say here, which is 0, 0, 1. So we save four floats. So we end up on 12 floats instead of 16 floats for a 4x4 matrix. So with this, we can get a camera working and also get multiple models and instances and stuff like that. So we've got all the standard sort of like, translation, scale, rotation things. And we also have ways of multiplying, right? Multiplying a vector and a point and doing an inverse of that transform as well. So we should have all the stuff that we need just to get stuff going. We might need to do some more things later, but should be enough. So basically we build up the game. We have this sort of like ship thing that can sort of like fly around, and I'm using the standard sort of controls, like standard movement controls on the keyboard to move it around, and I've got two keys to make it go up and down. What we want to do instead is remap those to be the camera instead, and then we're going to move the camera around, and we've got to make the different shaders account for this new camera, because right now the camera is just around zero, like the 0, 0 in the world, and we need to adjust those shaders. So we actually have three different ways of rendering, and they're all running at the same time right now. So they're just rendered on top of each other. We've got they're all basically a sphere ray tracer, but they're different ways of accelerating it. We've got screen space tiles, frustum space voxels that we bin them in, so they're froxels, and a BVH. I should probably rename this to BVH, because that would be better. Hey there, Chillaxathor, welcome back. How you been? It's been a while. How you been, sir? Good to see you. So we'll start off by. So here's the thing, right? We're just gonna have one main camera for now, right? Like, so essentially, we want this to be visible to all shaders. So I think this is where we need some form of like basically a globals buffer, where it's just it's just a buffer filled with just a bunch of data that, and we kind of needed this for a while, but I was just super lazy about it. So in graphics shared, I want to chuck in a thing called globals. Yeah, the code base is getting a little messy, but that's okay. We're just doing some R&D at the moment. So as soon as we've like done the R&D, we can do a pass over and clean up the code base. Right now, we don't know what we want to render yet. So as soon as this all checks out and we're happy with it, I'll do a cleanup pass on the code base. But yeah, these are the graphics globals. So you can put anything in here that we want. So basically we want that transform, right? The transform 3D for view from world, right? This is basically the camera matrix. And we will probably want the opposite way around. So you go from view space into the world space. And we probably want the field of view, right? Because that's kind of like hard-coded everywhere and it's really dumb. There's also a few where we've got some custom allocators. We've got some sphere, tiled. Wait, what did I call that? That's the word I. Tile spheres allocator. Yep. Besides getting sick, I'm okay. Fair play. Yeah, there's a few people got cold lately. Just all of a sudden around where I live. So yeah, there's a cold going about. But yeah, but I'm glad you didn't get otherwise. How am I doing? Yeah, not doing bad. Just been doing lots of things, you know, working, looking after baby, and just exercising and about it, but keeping busy. Yeah, I've got like from next week, I'm off work until next year. So super cool. So lots of relaxing. I'll still be doing some streaming, but obviously around the Christmas time, gonna obviously not stream too close to Christmas, that sort of thing. What else? But yeah, doing good overall. Yeah. Oh yeah, it's gonna be amazing. We get to have a bit of a break, you know? Just relax. Catch up with some sleep. Because, yeah, with the baby and everything, sleep's been a bit here and there. It's gonna be good. So allocator offset. Do I really want to call it offset? And probably capacity. See, I like the word offset meaning bytes, in offset and bytes. But it's kind of like next index, we'll call it. Better name. So essentially, like when we bin the spheres in a tile into tile space, we basically bump allocate it from a buffer. So we just want to keep that in a accessible place. And we just got some massive buffer. We just bin everything in. It's gonna be amazing. So we should really make this change now. So we need to make a new one called, just call it globals. Globals buffer ID, and every shader is going to get access to this. We can actually have it built in, and if I have it built in, it means I don't even have to pass it around. So if we go into the GPU abstraction, we already do this for the upload buffers and the readback buffers. So let's just add another one and call it globals, and it could be a custom buffer. Where is the bugger though? Here it is. So the surface is at 0, then it's upload, readback, perfect. Right, so what I want to do is call another one globals. So these basically declare like because we use because our resources are accessed via an index in the shader, where we use the bindless our resources are accessed in a bindless way. This means that we pass an index to the shader, and we use that index to fetch our buffer every time we want to use it in a shader. And it just means it's super flexible and really great. But it means we can basically hard code a bunch of these guys. And whenever we want to refer to it in the shader, or whenever we want to get access to it in the shader, it's just a hard-coded index that is compiled into the shader. And we don't have to pass any information to the shader to get access to it. So we've got this lovely thing here. We've just got to figure out how do I get access to it. I've just got to remember what I did. So I added one of these guys here. Oh, bloody hell. Or maybe not that then. I've messed up my config or something. Oh well. Right, so what we want to do is go into, yeah, so you can get the, right, so you get the surface one. Be back. Thank you, sir. Thank you, sir. Okay, so we've added that new globals thing into the GPU abstraction. So where does that get initialized? Let's go to GPU in it. We need to somehow initialize this buffer. Right, so it goes over all of the built-in ones and then allocates from the object pool the resource. But I don't think it initializes it all. So we've got one of these. Okay. Right, that's surface one. Damn, that's surface one. Oh, it's in the internal. Ooh. So these are in the internals, whereas surface one was in a public header. Gotcha. So this globals one is publicly accessible outside of the GPU sort of module, right? So, but we need a way to initialize it, right? So what we need when we boot up the, right, we've got this. My whole thing is buggered. Damn Neovim. Yeah, so basically we need to go to the header. And when we initialize this guy, we want to basically a size of globals that gets passed in, and then we'll instantiate this buffer. Wait a minute, do we need two buffers? Because they need to get swapped every... No, they could just be uploaded to. Yeah, they'll get uploaded to. Only one buffer. Excellent. So the GPU system... How do we initialize these? It's all done in the back end, isn't it? Right, so is the GPU resource in it? Or it's buffer in it, isn't it? Excellent. So there's an allocate. Right, so I think we literally just want to do... Oh. if index equals GPU resource globals buffer, we'll just do it in a different way. Let's call it globals, right? Just the globals buffer, and that'll be from the spec. Size of globals. Excellent. So that will now be created. We just got to find a way. We've got to provide a way for the outer. So we need a way to get access to this. So you want to say like. So where's the upload? So you can say upload buffer, upload texture, upload manual, and you can say upload globals. And what that does is it gives you back a pointer to write the globals data structure in. And yeah, that'd be pretty cool. So that'd be pretty dope. So it's just going to call upload buffer. Now the resource ID that we're going to use, is going to be the right. So where do we get that? So upload buffer res ID. Excellent. So you need to add a new one of these. Call it global buffer res ID. So as you can tell, right, we've got all of these kind of globally accessible resources that we don't even have to pass up to the shader. We can just read from an upload buffer on the GPU. We can write back to a readback buffer. And there's a few of them. There's one where it's just a readback one, or we just sort of say, hey, I want to read back from something. And it will allocate a certain space and you can write back into that space. Then there's other ones which is more automated. Like there's a readback command buffer. So you can have the GPU sort of like decide on logic that the CPU needs to act on. So it's like a reverse command buffer. I've not got any use for that yet, but it's just an idea that I've had, and I've put it in there because it wasn't too much work. And there's a debug one as well for any debug mode, which could be useful, but yeah. And then I got a printf buffer, so I can print like from shaders, read that back, and then like just display it in the terminal. So here's a new one, which is a global buffer where we can basically upload a massive structure filled with globals. Well, massive, depends how big it ends up being. But it's just a bunch of like fields or arrays in there as well that any shader can access. So it's going to be super, super sweet. Now, so that's there. So when we do that sort of upload globals, we can literally just pull that there like that. The offset is 0, and the size is GPU. Have we got a copy of the spec? We don't. Damn it. I need to keep a copy of that somewhere. Where's the GPU in it? Well, I don't need to know the size. Where's buffer in it? Oh, we do put the size in there. Okay, so what we'll do then is we'll just get. Is there a resource get? Yeah. Buffer.size. Boom. Okay. So. Right, jobs are good. And so that'll just basically allocate space in the upload buffer, give you back a pointer, you write to that, and then it will magically appear in the buffer that you requested it to be in. So that is basically everything now. in the internals. But there's one more extra thing. We want a way to actually access this structure. So we probably want in some form of GPU accessible code. So in the shared header, this is how we access the... No, not the shared one, just the shader only one. There's GPU shader, this guy. So this one allows us to like load from the upload buffer or store to the readback buffer. And some other things as well, like printing. But we want to add a new one. And this new one is literally going to be, I want to get a field back from this. Yeah, I want to read back a field. GPU global. And you can basically, you know, get your sort of access expression. So you'll essentially get this globals buffer, which is just an integer. We'll cast that. We can't cast it into the type. We don't know what the type is. So, right, so we'll pass in a t, but we'll make another macro that does it properly. So we'll cast in t, so you go HCC read-only buffer of t, cast that into that, do the access to access the zero element, and then you put in your access expression. And that right there is how it will read from the global buffer. So we need to make another one of these guys, unfortunately, in the graphics part of it. Graphics shaders, I guess. Oh yeah, I've already got it. Let's do it up here. Right, what do I want to do? I'll put it in. So GFX global access expression. That will call GPU global. GPU global. And then the t variable is GFX global. Like that. Boom. Isn't she amazing? So all we have to do now is actually upload this thing, and then we can actually just start using it. So where do we go now? All right. So when we render a frame, so I think we have to do the upload code outside of the loop, which is really silly. But let's just do it right here. So what we want to do is so we basically get that GFX globals. And then we just say, okay, globals. And then you go GPU, upload, globals. Now from here we can just set all of that lovely stuff. So there's our view from world, which is where our camera stuff is going to go. But let's just get everything. We'll leave these guys to happen in just 1 second. But field of view, that was apparently 120 right now. I had the excessive FOV because I was testing extremes, but with some things. So let's just keep it as that for now. So tile allocator next index 0, tile allocator capacity. Good point, there's a capacity. What is the capacity? Where's the tile spheres? Right, spheres cap. Good number. Then there's Froxel. Okay. What else? I think, yeah, that's it. Good. So that's going to upload. Boom. So that's going to upload that to the GPU into that buffer, and it's now going to be globally accessible via that new lovely macro that we got. So we just got to go ahead and actually fix all of those things. So CPU side, where's the GPU? Yeah, still got compile. Wait, it compiles GPU first, doesn't it? Is it? I don't know why that's allowed to work. Right, so this allocator thing, this needs to go, where we allocate the tiles. Because it's just a global thing now. This used to just be a buffer with an integer at the start, which kept track of a counter. But now that's in one big global buffer. That's super, super sweet. So for the tile and Froxel ones, they don't need that. So instead, the way we do it is we literally just do so we should be able to just do something like this, right? GFX global, and then it's tile sphere allocated next index, and we just bump it to allocate those. Then this one here is in the Froxels. So this is the Froxel one. And there we go. So there's probably more of these. Shoot, what's this complaining about? Cannot cast signed in. Damn it. Just signed in. Okay. Yeah, can't cast it to a resource type for some reason. It's got to be U32. I don't know why my compiler does that. So we need to cast this to a U32 first. This is just an enum. So its default is signed unless you make it unsigned. Yeah, and that will just cast into this type here, which is basically a 32-bit integer as well. Just an index, it's just typed. Excellent, so we're CPU side again. So no longer do we have to zero this buffer, the allocator buffer. No longer do we have to pass this allocator buffer in and synchronize on it. Another great thing about this globals thing is that it gets synchronized once, which I've just remembered now I still need to do in the GPU side of the code. So we hop into the GPU side of the code. Specifically, we go into the Vulkan backend. Now this is where it gets a little bit crazy Vulkan code, but it's fine. So when we start the frame, we do some synchronization on some built-in stuff right at the start. So we wait for 2 frames to go to finish on the GPU. So we can start using some of the buffers that are used by that one, basically. So there's basically there's one frame which the CPU is meant to write to, so it writes to some buffers for the GPU to use the next frame. And then while it's writing to one CPU side, the GPU is using the other one, right? The other version of it, and reading from that one, and then it swaps them around. So we just wait for, this is where the CPU is running faster than the GPU, and it just has to wait because it's already written its stuff out and it wants to go again, but the GPU is not finished. Then we acquire the next image, swap chain image to render to, which is the display basically, or the window, whatever you want to call it. Here we flush the caches for the upload buffer. Here we invalidate the readback buffers. So this invalidates the caches on the GPU. This invalidates the caches on the CPU, right? Because the GPU is written to that data, but the CPU's caches has invalid information, so it needs to be invalidated. So when you next read from it, it doesn't pull it from the L1 or L3 cache or whatever, right? Instead, it has to do an actual memory access from main memory. So then we get our internal resources. We throw, oh, I didn't put them in the descriptor set. Right, we need to put them in that descriptor set, because if not, when we say, hey, access this buffer of index 6, there's got to be a descriptor there. If not, it can't access the proper stuff, right? Come on. I swear that was the thing. GP globals. Oh, we don't have to set this. I just remembered. Yeah, we don't have to set that. Oh, wait a minute. These are set once when you boot the game. Sorry, when you these are set up one. All right, fill the update with null descriptors. When you initialize the buffer, right? Yeah, when you initialize the buffer, it will store it in this descriptor thing anyway. Okay, so we don't actually have to do it because we call the native initializer. Okay, so that's not quite what we need to do, but we do need to do that synchronization code still. So we start a command buffer. If we're in profiling mode, we can sort of read back the profile markers and get our profile data basically. We bind our descriptor sets. So every dispatch uses those descriptors and pipeline layout. Right, here's the synchronization code, that scary synchronization code. So basically we transition, right before we copy the uploaded data, place a barrier, right? We can, yeah, okay, so this just transitions the barrier. Sorry, this transitions the upload buffer from host, right? It's saying, oh, it's been written by the host, and it's going to be transitioned into copy read. So we're going to copy it to the actual destination buffers, then we go over and copy it, right? This is all the copy stuff into the actual places. And we record that to the command buffer. But where's the proper sort of... Right, this will transition the readback buffers. I think I could just stick it here. Yeah, this is the last pipeline barrier, so we'll stick it in here. So this one basically transitions the readback stuff from host read into compute shader write, so the compute shader can just write to the readback buffers and that. So in here, we just want to copy it, and this is saying, hey, Actually, no, we didn't have to transition it at all. It's being uploaded to like any other uploaded buffer, meaning it should just get transitioned. Yeah, it'll be transitioned via this code here because it's just an upload entry, like an. Excellent. This is amazing. Okay, so we just got to get compiling now. BVH. Right, we've changed something fundamental. So something could break. But if it does, I'll be right back. Let's see. Okay, CPU crash, no worries. Right, we didn't set that. We didn't initialize the GPU stuff properly. So why isn't my GPU being initialized in here? Because it's initialized in the main C file. Haha. Size of global, size of size of GFX globals. Okay. Now, again, if the stream dies, I will be right back, but it shouldn't do, because AMD hardware sucks. Right, what's the sec fault? What? This is not readable stack trace. What have you done? So my stack trace thing is crashing. Isn't that amazing? So we can put a breakpoint. Right, okay, luckily I opened up in GDB and it figured it out. So this seg faulted for some reason. Right. The GP backend wasn't initialized yet, and it called a null pointer because that's a function pointer. And it's not been initialized yet. So, what can I do to fix that? That's a good question. Let's figure that one out. So we just got to manually do that. So we'll just do something like, let's manually do what this does. Because it's going to allocate the resource. GPU resource get. GPU globals buffer res. Right, so we'll just assert that. So initialize globals buffer. Interesting. All right. so we just get rid of that we put in. So it just allocates those built in guys. So that'll work because it would initialize the backend now. We're not missing anything else, I don't think. Let's give that a run. Right, if the GPU crashes, I'll be right back. You know the drill. All right, we're still running. Look at that. So the what is that buffer zeroing again? Yeah, so just to check to make sure, we're going to turn off the BVH renderer and see, because it could be, it's the last one to render and it renders on top of the others. So it could be masking the fact that it's actually not working. What font I use for the IDE, use Liberation Mono. It's basically a free font. You can actually use it in commercial stuff. You just gotta, you know, say you're using it. It's a pretty nice font. I like it. So we disable the BVH rendering. Does it still work? Yes. So it's allocating the stuff properly using that new lovely globals structure, which is super sweet because now our camera system can use that. And so this is where we get to this today. So here we zero the sphere's Froxel buffer. Why do we zero that? I think we zeroed the wrong one. Why do I want to zero the sphere's Froxel buffer? Isn't that when we just overwrite all that data anyway? It's quite a big buffer and we're zeroing it. What are we doing? Oh, we atomic add the spheres count. Right. Yeah. Right, we'll think about that when we actually optimize it. Okay, so we've got this lovely globals data structure, which is purely accessible from shaders. Now, so that's super great. So let's plug it all in. So if we disable everything but the screen space tiled ray tracer. So disabling the Froxel ray tracer, the BVH ray tracer, and we're just going to use one of the renderers for now because, and then we'll progressively get the other ones working, right? So, right, what do we want to achieve? So, what we need is we need access to the internal header, and so we could just store the whole globals thing in here, and then it's just a mem copy away. And the way we can set any time, and no, it's probably bad. I don't know, because some of them are just going to be hard coded to like 0 or something. But then again, it just makes it easier to actually copy it over. No, I think it's not good to... Yeah. Okay. So we're just going to have like a little static variable for now. It's not really the best idea, but this is ultimately going to come from the game. So view from world. So transform 3D. So, you know, so what we're going to do is have our view I also have transform 3D functions that we have. So it needs to be initialized to identity, right? That's kind of a bit of a problem with it. So I guess we'll just do the classic, just do the classic, hey, I've got to initialize this sort of static variable. Identity trans. Oh, is it a constant, is it? That money. Oh, that means I can just do this. Boom. Even better. So, yeah, so now what we need to do is wire up those controls, right? Where are these controls at? They're probably higher up, so let me bring it higher up. No, it's not gonna do this. Leave it here. So I've got these controls for the key. What was the key code? Yeah. So this is where we move the ship around. Should we do that with the camera as well? Okay, so we're gonna basically produce some form of like translation. Oh yeah. So they press the W key, they want to go down the Z. So yeah, a lot of this is just, hey, right. What is DT? What is speed? Good question. Just a bunch of hard-coded stuff. DT, do we have proper DT? No, we don't. Because we never need it yet. I'm bothered, like, I've got the code somewhere to sort of, query the time and that, but I've just not bothered yet because that's quicker. So this will allow us to translate. Then we want to produce on a new matrix, and this will be known as the new view from old view matrix. So this one would just be simply so yeah, I think it returns it by value and it's all inline. Yeah, because we want to be able to use it in shader code and we don't have pointers in shader code, so the way it goes. So there we go, there's our new view from old view, which means we can use the whole, we can just clearly, well, I'm hoping this is right. We can all jump around for joy in a second when it works. The idea is that we should, using this naming convention, be able to get this right. So the idea is you're constructing something to translate into a new, where the new view is gonna be. Is that right? Am I thinking about that right? You might have to negate the translation. Because if I'm standing at 0, 0 and I go, oh, hey, the view is forward. Maybe that's fine. Yeah, maybe that is right. Maybe I'm overthinking it. So yeah, so we get this new view from old view. So we basically just line up old view and old view here, and then do the multiply, and that should be it. So that's our new view from world. This is static, so it's persistent and updated every frame. And if we don't need to update it, it'll just be an identity matrix and multiply over an identity, right? It should be fine. So, with all that said, we should literally just be able to set this to view from world, and this one to inverse, transform view from world, and that'll produce a world from view. And there we go. So, this is everything we need to now start adjusting the shader code. So if we hop over into the shader code, we've got 3 shaders. If you guys familiar with what we got. We've got some screen tiles that we bin our spheres into, and then we essentially, when we ray trace, we do a whole screen dispatch. The pixel looks at the tile it's in, and it gets a lovely little array of the spheres to render, and it'll essentially just do a ray versus sphere for all of those guys and find the closest one and done, and it renders it. So we've got 3 shaders. One does a first pass and calculates how many spheres did it bin, but it doesn't actually bin them. And then it does this. Actually, there's 4 shaders. Then it does a allocate where it goes over all the bins, all the tiles, and just bump allocates some sphere memory, and then it actually does the binning, and then we actually do the ray tracing. So if we go into the shader code, we can find all this counts. So here, so this, so also something to note. This is not the most optimized way to do it. We're basically repeating this code twice. But when we get like multiple models and some more features in, we're going to build a little scene up and just do an optimization pass on all 3 methods and just see which one is the best and just roll with that from then on out. So as you can tell, there's a whole bunch of this stuff. Fixed camera stuff. And also, I've probably underlooked a lot of this. So we've just got to double check and make sure we don't actually have to translate from world space to view space. This is a great day because we can remove to-do labels. Some of the best feelings. So it's saying here that we've got to use the transform matrix instead, and obviously translate the sphere from world space into view space. And I forgot to mention we need to play the music. So we've got a field of view, very easy. We can literally just do this, right? Globals, FOV, get the field of view from the globals, and done. So camera position, what are we going to do with this little bugger? So this one's going to get right. We can ignore this. This is the occlusion buffer code, which we tried. It didn't work out, but I really want to try it again later. That's why I've kept it here. The reason why I scrapped it is because I was like, oh, the BVH might not even need an occlusion buffer. Turns out we're kind of going back to screen space solutions as well because they're quicker. So we're going to have 2 solutions, the hope is. A screen space solution and an in-world solution for general lighting. This one, I guess we'll just get... Oh, we still need to calculate the screen out of pounds. Damn it, okay. What does this guy do? Okay, so this does the translation of the sphere here. No, it just needs the... Wait a minute. Camera origin to sphere. Yeah, if we translate that sphere position, that'll give us it. But also we can just access the globals from any shader, any function in the shader. So it's the beauty of globals. So they don't even need to pass in any of this stuff really. Yeah, it's a pretty good idea. Let's roll with that. Less parameters. Alright, here we go. So just delete it. Delete that. Pixel size and near depth. Right. See, part of me's thinking we might... Yeah, let's pre-translate it. So what thing called a sphere. Is that in the shared header? I think we want to do this a lot, right? We want to translate our sphere. Center position and the radius. Not so much the color. There'll probably be some other stuff in here. Yeah. But yeah, maybe we should make a little function for that. So it's just going to be something like... So the function is going to be something like... Well, so I want to translate it. I do want a general one to just apply a transform. So I think we just... Oh, obviously need the sphere to come in. So return the sphere. So essentially we'll just be like, oh yeah, sphere dot this equals multiply point and sphere center position. Then we want to also vector. Wait a minute. What we translate? We only want to do the scale, isn't it? So the problem with like non-uniform scale on a sphere, yeah, it doesn't really work well, right? So maybe you could take the maximum scale and just apply that, an actual new sphere, but it doesn't really work. It's not really a sphere anymore. So maybe we should basically ban non-uniform scale. Yeah. Should we just use... So, if it's uniformly scaled, it's fine. But non-uniform scale... It's almost easy to trace ellipsoids as spheres. Is it really? Interesting. Yeah. See, the thing is about the sphere, though, and I was thinking more about that procedural material stuff. And hey there, Rasmuska, how you doing? Oh, I need to give you a little surprise. Welcome to the club, my friend. How you doing? Yeah, you've been didn't give me lots of good information in the past few streams, so I thought I'll give you VIP there. Um, I was thinking more about the procedural material stuff, and if it's a sphere, you know, there's that nice sort of see, I forget what it's. I was looking at array binning the other day, and yeah, this is it. This is it, and it show like I always forget this name. Octahedral space. There we go. So the beauty is we could play around with basically mapping a sphere to this octahedral space, and then you basically get texture wrapping. Well, it's a great way to sort of do some textures, have some textures that map to a sphere in a nice way. So if it's a sphere, we could use this thing when we do our sort of play around with texturing these guys. And there's so many things we can do with this, more than just texturing. But yeah, I'm interested in if the ellipsoid would bugger it up. But yeah, if you have any thoughts on that, that would be appreciated. I don't know if the ellipsoid will bug that up. Okay, think about non-uniform scaling, maybe ellipsoid. Do I want to use 2D maps? I'm not sure. I do not know. Yeah, the problem is you have to work out the ellipsoid from a sphere, but I'm sure there's some way around that. But anyway, right, sort of this thing. So it should make it easier. Better to use functions in 3D, in your opinion. What? Oh, you mean like the procedural texturing stuff? See procedural texture in 3D, right? Like a 3D texture. But yeah, I was thinking not necessarily about. I was thinking about just texturing in general. There might be some. Yeah, maybe. Yeah, maybe there's some neat like 2D textures we could use with it. But we'll see. So we should just literally be able to get this sphere out, and I don't think we really care about it. Sphere transform. I don't think we care about it in world space. So we can literally just do this, right? GFX globals view from world. So they're currently in world space. We don't have a concept of a model. In the future, when we've been, we're gonna have to translate it from local space to world space to view space. But yeah, we'll think about that when we get to that problem. So we've got this new sphere, which is in view space. It's now in view space. Voila. So that works even better. So this calculate bounds now needs sphere in view space. And if it's not in view space, there's a big problem. Go for all these different versions where I tried to make a better bounding box. Yeah, anyway, so now the camera origin to sphere is literally just the position. Dun dun dun. So I don't need camera origin anymore. Boom. Okay. So, what else? Alright, let's just double check this then. The sphere will be an ellipsoid in view space because of the perspective projection. Are you sure? Because you go from like that's from view to projection. Yeah. Well, when you go from view to projection, right? That's when it gets distorted, right? But we're only working. Let me get the graph out. So sure, you have the view frustum. Whoops, let's draw that better. So you have the view frustum. You have your sphere. You know, maybe the world origin is like here, and the camera origin is here. Or the view origin, whatever we're gonna call it, is here. So yeah, I haven't done any fancy maths where I've messed around with the projection though. Right, I'm just sort of translating it back into here. Like that's all I'm doing is I'm just translating it to there. I could have swore that the view projection is, or the view to projection is where it sort of condenses it down, but I don't have that in my pipeline because it's done in view space, right? Just translation is fine. Oh, we talking about when you if you rotate. Oh yeah, I'm not translating it into the frustum space itself. It's still like what do you call it? Yeah, it's not non-uniformly scaled. Yet. But we're not doing any of that at the moment. Yeah, I'm not sure what to do around that yet. Okay, so I don't think there's anything else that we need to keep an eye, need to look at in regard to this. Rigid transform. What does that mean? In mathematics, rigid transform is a geometric transform of Euclidean space that preserves the Euclidean distance in every pair of points. So rotations, translations, reflections, or any sequence of those. Right, so obviously scaling is out. Non-uniform scaling, be out the picture. And skewing. Let's update that code even though it's... Okay, so I think this binning code is fine. We've just got to update the... Sorry, this is the calculating the counts. So it just calculates the counts. I'm curious, did I delete the wrong code? No, it's fine. That's fine. It does zero this buffer, so that's fine. Right, so this one doesn't need any of the corrections, but this one does need the corrections. It's basically a copy-paste of the other shader. So we just want to copy-paste all of this. And get rid of these to-do labels as well. All right. Cool. Top binning. Yeah, so now that's the three shaders done. There's a fourth shader, which is the actual ray tracer. Find it. This one. So with this one, you've got them... Wait, it's binning them in view space. It actually bins them in view space. See, it puts that sphere in there which was transformed. So, when we access this, we don't have to worry about anything. So, we can delete that. Ray origin. Probably delete that. Field of view, global. So we just need a ray direction now. We could probably calculate the like a different spaced ray when we need it. So this is ray origins. Okay, so this is all the debug visualizer code. There's a lot of debug visualizer code. Right, ray versus sphere, ray origin. So this ray origin is really just going to be 0, 0. Cool. Is there anything else? So this is the anti-aliasing that we've tried to do within the shader. It's not working at the moment because we've just decided to do something else, but it was working before. Yeah, I don't think there's any other transforms to do now. Let's take this boy for a spin. So there's nothing called globals, it's called global. Um, okay. So apparently this is everything all plugged in now. So fingers crossed this actually works. Give us a go. If the stream dies, I'll be right back, but it should be fine. Okay, so I'm pressing the controls. Nothing's happening. Like, we're moving the thing still, but we should be following it. So what we should probably do is disable the movement controls. Uh, yeah. So here's the thing, right? Well, this view from wild, you know. We could just enable one of these. To keep increasing and just see what that does. Let's just keep increasing the Z as if we're just holding it forward. What does it do? Right, it works. so what's happening? If we were to do this, does it still do the same thing? Without the static there, it's just not persistent anymore. Alright, it moves. So which means we're basically moving in the wrong direction, in a way. So if we were to negate, I think I did need to negate it. Okay, now it's working perfectly. I'm pressing the controls and it's not moving because the ship is moving with me. So we disable that code. So this is where it changes where the ship is in world space. Now we've got ourselves a camera which moves. Bum, bum, bum. So now the camera's moving. So the next thing I want to do is actually get the looking working, right? So I think have we got the trap mouse stuff in the operating system layer? The mouse hide and show. I think it does the trapping. So hide pointer, trap it in the bounds of the window. Right, it would kind of be nice. Actually, no, not. But yeah, I think we need to like. So we need to have a way that can like, even when it or when the application closes, like it just doesn't show. So I think in the main file we've got this sort of like exit, game exit, this beautiful, lovely. So it flushes all these guys. We should also just say, hey, by the way, OS, sort of like mouse. So I think we should have that stuff separate, maybe. So there's hide. Yeah, okay. Virtual mouse, show. So when we build up the game, I'm not sure if I've actually tried this stuff before, but let's give it a go anyway. YOLO. Because what we want to be able to do is move the mouse and the camera moves right, but if we end up moving out of the window, it'd just be a bit annoying. So OS mouse, virtual mouse, hide. So my mouse cursor could disappear forever, but hopefully not, right? Right, it's still here. It still exists. Oh, but it's trapped. That's good enough for now. Right, how do I close it? Okay, closing it was fine. And if I were to do this, I'm not free, but I closed it and it was fine. Okay, I'm glad that that's the way it works. So at least we can be trapped inside the window, and we can enable and disable that. So if we can now hook up the mouse stuff, right? Which would be super awesome. Oh, I just flicked my page down key off. Yeah. Right. So what, view from world? Here we go. So we also want some form of translation. Sorry, rotation. If virtual mouse relative position, shall we say? Dot X. We want to rotate around the Z axis. Wait, around the Y axis. Call it look speed. Times look speed times dt. And then you want to do to look around the Y to go up and down, right? You want to use the Z axis, the X axis, is that right? Yeah, because the Z is used for twisting. And now we need another one. So this would be your translation transform. Then you want your rotation transform. So I think we might want to negate it as well. I'm not sure. We'll have a think about it. So the idea is you want it to translate, so rotate first and then translate. So you want to do like a multiply where your translate's on the left and your rotate is on the right, because you want that one to happen first. And that'll be your new view from old view, and then you can multiply that and get your new view from world. So fingers crossed that works fine. Hey there, Texa. How's it going? Welcome to the stream. Hey, how are you? Right, so clearly we've buggered it, but look at The sensitivity on that one is over 9,000. We can see the balls, and they're really warped in some way. Whoopsie. Um. Yeah, it's in radians, isn't it? So 100 is way too much. We could just do 1 times by 1. Maybe I got my yeah, I think I got my matrices the wrong way around. Those balls are just the way they're popping into space. Oh. Yeah, I think I got those the wrong way around. That didn't seem to fix it. Is it because I negated the translation? Very weird. The balls are like shrinking and getting bigger. Oh, is it because I negated it? They're definitely stretching though. Wait, the stretching is fine. Because that's the high field of view. Sorry, these are my spaceship noises. And I've lost where my balls are. Wait, this is not right. My scaling's going negative. The scaling's going negative on the balls. Remember we multiplied it by the scale? So when you look at a certain angle, it's like the balls start shrinking. And then they go negative. So they go inside out, right? I think I know what's going on. So we apply... So if we look here, we do this. We scale our radius. But why would it go negative? So you do your rotates and stuff. Right, maybe I've got to do all of them and it would do... Like, we only want it to scale. Trying to think what it's doing exactly. But as soon as you rotate... Yeah, we might want to take the max of the scales. I'm not sure if this is correct. The arena behind you, you must be using the magnitude of the axis and not the... Oh, the magnitude of the axis. Right. I see. Ah, I didn't know that. So what you're saying is just do one of these boys, and then Bob's your uncle. Oh yeah, we're balling. I don't know why I'm twisted. Oh yeah, I remember doing this before. Oh yeah, I remember we had this bug before. This is cool though. So you sort of do this and it rotates. And I think I remember someone saying That's because I'm doing both of them at the same time. I need them to be different, separate matrices, and you multiply them in a certain order. That's right. That's right. That's right. Oh, past experiences. Yeah. So what we should already have is a translation. See, this one does it in x. It multiplies x by. Yeah, this is what you were saying. Saying last stream, Russ Musco, is we need to have. We need to multiply it like with y on the left or something like that, and then x on the right. Whereas the one that I made, where it does it in x, y, z order, whereas I need it the other way around. Do you have any gameplay at the moment? Nope. We're doing some rendering R&D. Yeah, rendering R&D. Why do? Yeah, because basically I want to prototype a game and get it all sort of designed. So I can sit here and think, oh, I want to make this game. But if I sit and just think, oh, I want to make this game, by the time I actually get to making this game, like, it's not gonna be the same game anymore. I would have lost it and the vision would be gone. So the idea is I want to sort of build, I'll do some sort of rendering R&D, find some sort of unique, well, maybe it's not unique, right? Things have been invented, before, most things you think about have already been invented, but some sort of uncommon art style, shall we say, and see if I get something which is like, oh, I can make something with this. Then I want to go over to the game design side of things and put something together, write it all down, have some clear sort of design pillars, so I don't lose track of what I'm making, basically. And just go from there, really. But yeah, so graphics R&D first, then game design. Just store the radians and recompute the matrix. If you want to preserve camera up. Oh. Yeah, but then when you get the whole lock thing, the whole you'll get the gimbal lock, right? Is that true? You get gimbal lock? Because you'll be no, you might not because you're just incrementing the radians, right? And you're not actually right. I think that might be fine. Yeah, it tilts. So what you're saying is do this. You'll get gimbal up, but you can't avoid it if you want to preserve camera up. Right. Interesting. But say if I were to have a quaternion, right? Could you like preserve camera up with a quaternion that fixes that will not have gimbal lock, or is that just unavoidable? Yeah, I can feel like we're building like a camera structure here now with like separate actual properties here. Just look up at the ceiling and decide what rotate sideways should do. Right. Yeah, because it will flip, wouldn't it? Yeah, you should also have some limits. Oh no, rotate sideways. Yeah. Yeah, I'll think about that. Right, so we recompute it every time rather than applying it. We'll just... So rather than applying it, we'll just overwrite it. And Bob's your uncle. Let's try that. It's looking a bit dodge. Maybe it's the X and Y. Or did I multiply? Maybe I shouldn't have negated it. What is going on? Do you lean to the sides or rotate around your spine? Yeah, the plan is to have like look left, look right, and look up and down, like a standard free cam. No tilt yet. I'm not sure if I need a tilt, to be honest. Something's weird. So the further I get away, I think I'm applying the translation and rotate in the wrong order because it's translating the ship thing in a way. You have a deadlock if your leather plates look straight up or straight. Yeah. Did I get these the wrong way around? Right, the X needs to be swapped around. Why does the X need to be swapped around? It's probably the Y, it's probably because the Y comes from... Yeah, I'm not quite sure. Okay, I think that's how we want. It's distorting on the ends because of the high field of view. Not any other reason, but if we look around, it's still tilting. Oh. Right, sum this up. So from here it's fine. Then if I translate, yes, it is meant to be the other way around. Translate first. I'm still orbiting around some space. Why am I orbiting around some space? Um, hmm. Um, See, if I negated those, it would just be working the other way around, right? Yeah, that's not right. So it just flips those around. Um, right, so what could be the problem? Well, I swap these X and Y's around again. Yeah, I did swap them around and it did. Yeah, so this one still rotates around. Right. When I swapped these around, what else happened? So with this version, oh wait a minute, let me. It might be fine actually. I don't know. Like, let's try it out. The full after translation, right? Okay, it makes sense. Oh, okay. I got my controls wrong. Yeah, this is weird. So I held the right hand. Oh, I'm not traveling the way I'm looking. Yeah, I'm not traveling the way I'm looking. Um, if I hold the D key and move right, I'm going forward because I'm looking to the right. Yeah, that feels wrong. So maybe it is the other way around. Uh, yes. Okay, maybe it's not though, because how did it respond? So in terms of like rotating the camera, does it work fine? In terms of rotating the camera, it's still not going up. We're still losing it a little bit when we go down to the corners. No, maybe that's the field of view. Yeah, and then when I look backwards, the rotate is backwards. And when I look backwards, it rotates backwards as well. You need to rotate the delta for the translation before you apply it. Ah, right. So we take the delta of the rotation, then apply it. Hmm. Mm-hmm. Right, I see. Right. So, okay. Is to rotate the delta of... Right. So this thing here needs to be translated by whatever the rotation currently is before I apply it. Yeah. This just feels very much like... Right, I see. So essentially what you want to get is get the... Just get this right. Produce these here. Produce your translation. Sorry, rotation. Name it with a space. Represented into C. Not sure I understand that part exactly. Name of a space. Oh, position in world, right, gotcha. Ah. So this is the rotation in view space. That's what you're saying, right? Right. That's a good point. So you do this. So you're your position in world. Right, I see now. Wait. So you want to apply the rotation. Right. Yeah, might need an inverse matrix maybe, is that right? Thinking about it, I'm not sure. Yeah, I see what you're saying. So you want to get this position in world. Probably name these better as well, to be honest. Um, your position in the hmm. Right. Yeah, so just apply the rotation and then you'll get the right, I think I got it. No, I think I don't. So, right, so before I accumulate it, okay, so you've got your sort of translation, your sort of offset. What space is this going to be in? Ideally, you want it to be moving in view space. So you need to translate it back. You need to rotate it back into world space, right? So you need the inverse translation. Okay, I think I've got this. Right. And then essentially what you'll do is you'll get your offset in world. So your offset in world will be multiply point delta in view. That's another way. Delta the delta in world. There we go. So we then want to use the inverse. Yeah. Inverse of rotation transform, which should probably be named better as well. Get to that in just a second. Delta in view. Great. Then we can apply position in world equals add assign delta, sorry, position in world with delta in world, right? And then we apply that like that, I think. Right, that sounds a lot better, but we'll see how it holds up. My Y is a bit messed up. But it's working. I'm going back and forward and I've gone around the other side. But now my Y... This is really weird. So the Y-axis is a bit messed up. It flips everything when I do a 180 degree. When I do a 180 degree turn, it flips. Goes the other way. Now, why would that be? So here it's going down and I go up, up, then I go down. Then I do a 180 turn. Then up goes up and down goes down. Why would that be? So the left and right still stay the same. So rotation in view. Could it be the order I'm multiplying these by? Rotation's in the wrong order. Okay. My left and right's buggered up. Let's flip it. Okay. So, look left, look right, go up, go down. Cool. We'll go past our ship. Down, then up. Oh yeah, left and right. Excellent. So, why does it look a bit skewed? Because it's midway through an animation. That's fine. Why does it look... Yeah. So that's the reason why it looks a bit of an odd... Like, it's... This actual animation that could be playing is just in a weird pose. So it's meant to look orientated that way. So I think that's actually all working. Thank you so much, Ross Musco. Appreciate it, sir. That's a real big help. Obviously, the sensitivity is super high. You know, it's like... But that's pretty cool. So we'll get the issue with the gimbal lock on that, but... You know, that's stuff to sort out when we need to. But that's pretty killer. So that sensitivity needs to be brought down a whole load. Oh, come on, it doesn't go anymore. You bugger. Right, it's a bit of a problem. Also, it probably needs to be started on 90. So pi, we get a slice of pie. Oh, wrong pi. It's all about the negative pi. We need to lose some weight. Ah! No, it needs to be rotated, not the x-axis, the what? Around the y, isn't it? What did I do wrong? I want it to be there. If it is 0. Okay, I think it's just a little bit odd. We're getting some random events coming in. Or something like that. I can't put a finger on it, but it should be alright. How do I handle font rendering and localization without losing my mind? I've not really thought about it yet. Um, like localization is easy, right? It's basically a lookup table of strings, right? That's not really a problem. But in terms of rendering, that's where the issue is. But yeah, basically you've got to look into how Unicode works and look how to render glyphs and multiple glyphs, that represent a single character. It's a bit of work, like quite a bit of work. I think like this person at work who basically wrote the whole system for the game at work, and it's a really impressive job to get that done. But yeah, I've not really looked into it too extensively. I sort of know the issues around it, but I don't. And I've seen how I kind of know the route to sort of achieve it, but I've not actually done it yet, so I can't really comment much on it, to be honest. Um, I wonder if we're just getting a bunch of crappy events in. Because it just starts off in the most odd angle. Like, I don't even move the mouse. Okay, it kind of just starts there. Maybe it's getting quite persistent now. It's really like pi divided by 4. Yeah, it's a mega die at that. Eh. Right, that's basically it, pi divided by 3. I don't know why it goes there, but it takes to go there. But anyway, something to solve for later. Not a big deal. Can I lock my mouse to the middle? Probably. I think the biggest issue though is that it's not. Yeah, we should look into that probably. Operating system, Linux. So we do this sort of hide. We do a warp, then we do a grab. And then we do a hide, but it doesn't actually hide. Um, ah. Right, I should be using the raw input. Where's my input devices? So we could make something, just call it main mouse, and then just use that. That's the way of doing it. Um, ideally we need a system on top of this. That can sort of like look at the input devices and sort of assign it to some form of like like a high level input thing. That doesn't work on the raw input device stuff. But yeah. Oh, fair play is cool, Heroic Shield. Thank you for watching them. Appreciate it. Yeah, we don't really do. I haven't done Unicode or that yet, but you know, when I get to the point of releasing it, I'll probably end up doing something. We'll see. But I'll probably just start off as English and see what sort of are the best ones to do from there. The real problem with localization really as well is size of text. That's another big bugger. You can have a button where you have the word like okay in there, right? But for some reason, I'm not sure the word okay. Maybe like the word, I don't know. Like a very small word in English might be a massive word in another language. And it basically changes the whole, like, your UI is different sizes now. Like, so you have to account for that. So it's a bit of a problem there too. Geotext hand is one of the most interesting things to see. Yeah, I've done a very basic UI, but we've just done a very simple. Like we basically just have a bitmap font. We just use a very old school sort of bitmap font, and we just render this. Yeah, we've done some sort of like immediate mode UI system. We've got a what else have we got? A little custom renderer as well, um, which is very flexible. It's like a SDF renderer. Um, Probably need to optimize it a bit more to be honest, but yeah, it's pretty cool. But yeah, we better just to get the input mouse because we can just use this, and this is the hardware relative position, and it's not the window manager's version. So I don't have like the main mouse ID. So you get a connected event, you be like, oh, I've got a mouse. We should probably use that. We should probably just get those in a nice little structure somewhere. We do have a sort of game.h. I think I can just do this, right? OS. Okay. And then do a keyboard as well. A gamepad in there as well, right? So. Bit of a bugger. I think I can do OS. Cool. So I think what we can literally do is like, there's a input device connected. And it supports, you can plug in multiple mice, multiple keyboards, and all that good stuff. I think we can literally just go, okay, if for this switch, right? Event, input device, OS, input device type. Don't know a way to get the type. It's called features. Because they can have multiple because it's basically like you can have a gamepad with a mouse on it, or a gamepad with a touchpad on it. Yeah, rightio. So we've already got that. Thank you for the follow. And this is equal to OS dot raw equals 0, so it's null. Then we can just take the ID, whack it in there, Bob's your uncle, job's good. Event, device, ID. So this is obviously like pure placeholder, but we don't have any multiplayer yet, so it does a good job for, you know, a very long time. Rightio. Jobs are good, and so now inside the graphics code, we can literally just use that instead. So what we should be doing is using mouse relative position, not virtual mouse, because virtual mouse is the one that you see in the operating system gives you. Mouse is literally the raw mouse, so we can just use ggame.mouse. Oh, Drago, thank you so much for the raid. Appreciate it, sir. No worries. How did the stream go? Oh, come on. How's that not wanting to work? Oh, yeah, because I'm using the damn virtual mouse still. Great, good to hear. What's up with my... That seems to go the other way. And it just keeps going now. Oh, yeah. I'm going to go to the edges of the screen. Because I'm using the raw mouse, so it just literally retrieves relative mouse movements no matter what the operating system's like virtual mouse cursor is doing, right? Cool. All right. So what we've got to do now is get the other two renderers to work. And then that is this whole camera thing done. So there's two more renderers to get working. It's the it's the Froxel one, and then it's the BVH one. So hopefully we can get that done pretty quick. I just need to take a quick break and get another drink. I need to hydrate. But it should be very quick to get these done. And then that means in the next streams we can just be doing models, model instances, and starting the work to really populate this scene out. Anyways, I'm just going to fetch some water and then we'll finish this off. Alright, BRB. Right, welcome back everybody. So, let's nail this. So we're going to transition over to the Froxel binning renderer. So we search for Froxel, we'll find it. It's this one here. So we'll disable the screen space renderer. So again, it's the same source of shaders, right? Calculate counts, then actual binning, and then the ray tracer will probably get changed as well. So it should be pretty easy to do, considering we've done it. Right. So we basically got rid of these boys. The field of view now comes from a new lovely global. Global's buffer. It's just in there, accessible and amazing. Then we want to do a sort of like a sphere transform using a view from world matrix. So it's going to translate that sphere into view space. Then what else do we need to do with this one? Just saying, hey, convert to view space. Already done. Already done. So is that this done? Yeah. So this is the Froxel binning code. Well, calculates the Froxels. This calculates the count. So I need to go to the binning code, which is basically copy paste. Alright. So we try and compile that. It compiles. So those two should work, right? If I have the seal of approval, it compiles, which means it's guaranteed to work, right? But we still need to fix the actual ray tracer. So this one is the Froxel binning, camera position, don't need that anymore. Ray origin, we kind of don't need that anymore as well, but I think we'll keep it. Down here. Right, FOV. Okay, so that's looking good. Anything else dotted about that stands out? So the sphere is going to be in view space now when it's binned. So pulling this out, it's a sphere in view space. So it all should just work. Right. Anything else dotted about that seems to... already in view space. Oh yeah, this is the copying code, isn't it? This is the debug code that we used to debug the Froxels basically. To see what Froxels the sphere landed in. Probably don't need that anymore, since the code is working. Okay, so it appears to be working. This is the Froxel renderer. We're able to rotate around here and go around the back. And all sorts of goodness, really. So, there we go, jobs again. Looks good. The Froxel one has less artifacts when you go through. I think the tiled one has a glitch or two. It's good. So we got another ray tracer. And that one is the BVH. BVH. So it's this set of shaders here. So BVH reset doesn't do anything. Calculate bounds. This one needs stuff. No, it doesn't. It's all in world space. Yeah. Prediction. This one can probably... I don't know what to do about this. The prediction. Yeah, I don't know what I want to do about this one. Alright. It's just cut off to maintain, and I don't think I'm going to need it anymore. If I delete it, it means I have to maintain it. Yes, we're going to have to delete it, because I'm going to make some more big changes. So let's get rid of it. Plus it's in thing git anyway. Right, that's good. This is that prediction stuff. Mispredict. Let's get rid of that mispredict stuff because it's not predicting anymore. Okay, so I'm glad that's removed. So now going back to when we was doing this sort of like, oh, you have to calculate the bounds. This is built into the BVH. This doesn't need to do anything because it's all in world space. We pick a sphere. Out of the sphere array, that's already in world space. But when we do the model instances, we're going to have to change this. But for now, just for the camera work, it's just the sphere array tracer. Now this one doesn't work in view space like the others work in. This one works in world space. So we need to move from... yeah, we need to do something different. But it's fine. Right. So you need a camera position. Now your direction, like if you're going in view space, you need to translate that into world space, right? So camera position, so that'll just be global world from view, so it's the other way around, dot translation. That's where the ray is going to be. Oh, I've got BVH viewer as well. That needs to be updated. But anyway, the FOV, that's another global. Now let's just fish that out of the global buffer. Pretty good. Another thing is, right, where was it? Oh yeah, this one. So this ray in view space. So that's the ray in view space, but the ray in world space is going to be multiply vector, right? Transform 3D. We're going to translate the ray direction view space using the using that, right? The world from view. Wait, it's the other way around, isn't it? You line it up like that. Okay. So that translates fine there. So now it's all in world space. You pick up the sphere, it's in world space. But obviously when we do model instances, we've got to bring them from local to world space, right? But yeah, we're on world space coords now. Should all be fine from here on out. Alright, let's take this boy for a spin. Hopefully it doesn't crash. Shouldn't do. Wait, why is it saying dot translation? Thank you, type checker. Alright. This is the BVH renderer. And you might be like, well, how did you know? Well, in the left-hand side, there's the performance stuff, and you say it's compute shader. Oh, we get some different colors. Those colors are now in world space, so we get. Oh man, that's pretty cool. We get a nice little outline. The further we go back. So yeah, the normal is actually in world space. In this shader. So we have got some different the way we're coloring it is different. But I'm interested by this thickening we're getting. This outline we're getting is from the anti-aliasing. Right? We kind of we've got this broken anti-aliasing code that's built into the ray tracer. And it gives us this sort of nice thick outline on the spheres, which I'm not sure is actually what I want, but it's pretty interesting, right? But yeah, that's cool. So then there is another one to technically get working, and that is the viewer, right, the BVH viewer. So that one's actually like pretty similar. Wait a minute, should this even be right? Sorry, it's axis lined in world space. Yes. You're building it in world space. So when you translate your ray into... Okay, this makes sense. Right, so that for a spin, I don't think we need to change anything. We need to enable the viewer though. Show BVH, enable. And right, there's our lovely boy. Yeah, I forgot that when we view the whole tree, we don't clip it. As you can tell, it's got this outline around the balls, which is a little bit off. That's the anti-aliasing. That's pretty cool. Maybe we don't have to do proper anti-aliasing, just do a border. I don't know. But yeah, this is the BVH that's getting traversed. You can even go inside it as well. It does mess up a bit though. I think as soon as you go inside the leaf node which has the balls in it, I think it doesn't like it. Something like that. But anyway, that's cool. Again, yeah, it's the same renderer, it's just got the viewer on top that sort of renders the boxes. But there we go, just look at that. So let's re-enable them all. Now what's interesting... Hey there, Captain Chica, how you doing? So re-enable them all. Still works, they all render on top of each other now. So yeah, it's just rendering the same scene over and over again with different ray tracing renderers. There we go. Eh? That's good one. Yeah. So this is literally just add camera. Sweet. So I'll put that up after the stream. So in the next stream, we're going to be working on models and model instances. I still need to think about where we're going to start with that. I better think about that off stream, but that'll be on Thursday at 8 PM GMT. And we're literally just going to try and populate this world, and just so we can do some performance testing and, you know, see which one of the renderers is better. And then go all in on that one, basically. Well, not all in. Use that for the main renderer. And the BVH will be used for lighting. So yeah, we're going to have some interesting times where we basically make more probably spaceship looking things, because it's probably quite easy to build spaceships using sign distance fields and just filling it with balls, right? We can change resolutions, you know, sizes of balls, how close the balls are together, you know, and just sort of see what we can get. Yeah. I'm stuck on triangle minimizing for my engine. What do you mean by minimizing, Captain Chica? Do you mean like when you sample? Minimize. What do you mean by it? Yeah, you can dunk your head inside that BVH. You can do the old yeah. So. I'm really digging the border that goes on these spheres when you get at a distance though. I'm real digging that. Let's see if we can see that again. Oh. Don't let me click when I have the game open. I'm really digging the yeah, it gets a nice little border around it. Look at that. Ugh. From the buggy anti-aliasing code. And I never knew this was a feature until I got the camera working. Line the number of triangles for performance reasons depending on the situation. Right, don't you mean like having a different level of detail for a mesh, right? Like a LOD, right? Yeah. Right, I need to find someone to rating it going, because my last day of work tomorrow, should probably get some good work done. But yeah, If you want any help, Captain Chica, check out the Discord. Maybe drop it in there. Got some people in there, including myself. Probably help you out. Yeah, definitely getting closer and closer, Illusion Man. Definitely so. Just you know, we're doing some rendering R&D. Probably want to get a good lighting solution in as well. Find that graphical art style, good performance, good lighting. You know, see what sort of visuals I can get, and then I'm like, then we can go and design a game. And then after that, we'll just be doing a bunch of engine work to support said game, right? Tons of prototyping while we're designing it, right? And then we'll write the whole bugger down and get it all, design pillars, all that lot. Right, I see some CPPs. I see PP. Maybe the only way is to see PP. Maybe. There's some OS dev, but Rust. Too safe for my liking. It's just an operating system, you know? What could go wrong? Outstanding progress since the pixel. Yeah, definitely. Things have come together. It's cool. Thank you so much, though. Appreciate the compliment. But yeah, I'll see you all on Thursday, 8 p.m. GMT, or Sunday, 6 p.m. GMT. Next week, I'll be able to do some more 6 p.m.s during the weekdays because I'm off work. But yeah, have a good rest of your week, everyone. Wait, no, it's Thursday now, isn't it? Damn it. Time travel. We time traveled. Right, I'll see you all Sunday. It's Thursday today. Right, I'll see you all on Sunday. Catch you later. Bye bye.